Good evening and welcome to the Q&A session 28 from the playlist of work, power and energy. The topic for the today's session is the instantaneous, how to find the instantaneous power and the average power. And this session is based on the session number 24 in which we have discussed in brief about the instantaneous power and the average power. So we can say that this session is in continuation of the session number 24 from the playlist of work, power and energy. Now this question which I have taken for this session was asked in the IIT-JEE main exam last year, and the question is, a body of mass 4 kg moves from the coordinates 3-4 meter to 6-10 meter in 4 seconds under the action of a force given by this equation, that is F is equal to 2I cap plus 3J cap Newton. Now this force has got two components, that is one component of 2 Newton is acting along the x-axis and another component is acting along the y-axis, and that is equal to 3 Newton. So we can say that this body is moving in the xy plane. So this is basically the x coordinate and this is the y coordinate. This is the x coordinate and this is the y coordinate. So here we have to find the ratio of average power to the instantaneous power in 4 seconds. We have 4 options here and we have to find the correct option. So first of all, we will revise what the instantaneous power and the average power is. So average power is equal to the total work done divided by the total time interval, and the instantaneous power, this is equal to dW upon dt. So this is basically the rate of work done at any moment of time, or we can say that this is also the rate of energy transfer at any moment of time or at any instant of time. So now dW is what? It is the small amount of work done in case of a very small displacement, say ds. So if the displacement is ds, then the work done is dW, then dW will be equal to F dot ds. This is the standard formula which I am using right now, divided by dt. Now F is the applied force. Now ds upon dt is what? This is the instantaneous velocity, F dot v. So the instantaneous power is equal to F dot v and the average power is equal to total work done divided by the total time interval. So these are the two important formulas which will be utilized in this question. So first of all, we will find the average power. So average power is equal to work done upon time, total work done. So work done upon time. Now work done is equal to F dot d. F is what? This is the applied force. D is the displacement. Now here the position vector of this body, the initial position vector of this body, initial position vector, of this body will be equal to 3I cap plus 4J cap. See, I cap is the unit vector which is along the x-axis and J is the unit vector along the y-axis. So I have written I have defined the position of this body in terms of this position vector, and under the influence of the force F here, this body will move to another location which is given by this, that is 610. So the final position vector will be equal to 6I cap plus 10J cap. So this is the final position vector. So the displacement vector basically will be the final position vector minus the initial position vector. So this will be equal to 6I cap minus 3I cap. So this is equal to 3I cap plus 10J cap minus 4J cap. This is equal to 6J cap. So this is the displacement vector. So the average power will be equal to F is equal to 2I plus 3J cap, 2I cap plus 3J cap dot D. This is equal to how much? This is equal to 3 I cap plus 6 j cap divided by 4. So this is equal to, now I cap dot I cap, I am not going into deep details from the topic of vectors. I hope that every one of you must be knowing that the value of I cap dot I cap is equal to 1, I cap dot j cap is equal to 0, and similarly j cap dot I cap is also equal to 0, j cap dot j cap is equal to 1, k cap dot k cap is equal to 1. So 2 I cap dot 3 I cap will be equal to 6, because I cap dot I cap is equal to 1. Now I cap dot j cap is equal to 0, so this, the multiplication of these two will give us 0. The multiplication of this 3 j cap dot 3 I cap will also be equal to 0, because j cap dot I cap is equal to 0, plus 3 into 3 18, 3 into 6, plus j cap dot j cap is equal to 1, so this is equal to 24 divided by 4. This is equal to 6 plus 18 by 4. 6 plus 18 divided by 4, this is equal to 24 by 4, and this is equal to 6 watt. So the average power is equal to 6 watt. So I will be just writing its value. Average power is equal to 6 watt. Now we have to find the value of instantaneous power. Now instantaneous power, as we have just discussed, this is equal to F dot V. So here F is given to us. Now V is what? It is the instantaneous velocity, and this is what we have to find here. Now since the particle here under the influence of this force will be moving in a straight line, it will move from this position to this position in a straight line. So we will be using the equation of motion for a constant acceleration in case of a straight line motion. So the equation of motion for a straight line when the acceleration is constant, there are three equations. S is equal to ut plus half at square, then v square is equal to u square plus 2as, and v is equal to u plus at. So here the force applied is equal to this value, mass is given to us, so the acceleration of the body will be equal to F by m, because F is equal to m into a. So this is equal to, F is equal to how much? 2I cap plus 3j cap divided by mass is 4 kg. So acceleration in the vector form, this is equal to 1 by 2I cap plus 3 by 4 j cap. So this is the acceleration of this body in the vector form. Now I will be using this equation now. V is equal to u plus at. Here V is the final velocity, u is the initial velocity, a is the acceleration, and t is the time. So here the velocity of this body after 4 seconds will be, now here u will be equal to 0 plus a is given to us, which is equal to 1 by 2 I cap plus 3 by 4 j cap, and into t, this is equal to 4. So this is equal to 2 I cap plus 3 j cap, and the unit will be in meters per second. So I'm writing the value of V on the top here, that is V is equal to 2 I cap plus 3 j cap meter per second. Now instantaneous power is equal to F dot V. F is equal to 2 I cap plus 3 j cap. Now V is 2 I cap plus 3 j cap. Here F is the applied force, which is equal to 2 I cap plus 3 j cap, and V we have already calculated, which is also equal to 2 I cap plus 3 j cap. Now, so this will give us 2 I cap dot 2 I cap, this will be equal to 4, plus 2 I cap dot 3 j cap, this will be equal to 0, because I cap dot j cap is equal to 0. Similarly, j cap dot I cap is also equal to 0. So the multiplication of these two terms will also be equal to 0 plus 3j cap dot 3j cap, this is equal to 9. This is equal to 13 watts. So the ratio of average power divided by instantaneous power, this will be equal to, average power was equal to 6 watt and the instantaneous power is equal to 13 watt. This is equal to 6 by 13. Or we can say that P average dot P, that is P average, that is the ratio of the average power to the instantaneous power. This is equal to 6:13. So here the correct option, this is the C option. So the correct option here will be C, that is 6:13. So here we have utilized a number of concepts. We have utilized the concept from the topic of vectors. We have taken the concepts, or we can say the equation of motion in a straight line for constant acceleration from the chapter of motion in a straight line, and we have also utilized the concepts or from the chapter of work, power and energy. So combining all those concepts, we were able to find the answer to this question. So in the next session, I will be discussing another type of a question from the same topic of instantaneous power and average power, and the chapter will definitely remain the same. So till then, have a nice day. Bye.